go there. Your time is going to most often be in years. Sometimes it's not, and then there's conversions that have to happen. But for what we're going to do with it, your time's going to be in years, okay? This says, use an exponential growth function to find the value of the investment after 25 years, okay? So just reading through that problem and knowing what these three things stand for, can you tell me what A should be? $1,400, okay? Your initial amount, what you started with, is $1,400. Okay, now here's the part that tends to get a little mixed up at times. What is your growth rate? 9%. How do you write 9% in decimal form? 0.09. Remember, 9% is like 9/100ths. So if you plug it into your calculator, 9 divided by 100, that's this, 0.09. Okay, so you are always going to write your percents as the decimal, which means, rule of thumb, you are always going to move your decimal point 2 to the right. 2 to the left. Okay, so maybe you want to just make a note of that. Whatever percent they give you, move your decimal point 2 to the left, and that will be the number you want to work with. Okay. On this problem, what is the time we're talking about? 25 years. So your T is going to be 25. Okay, so if you can just identify those three numbers, then it's really just plug them in. So you have Y equals, so I'm just plugging into this right now. A, which was 1,400, parentheses, 1 plus 0.09, and then T is 25. I want you to take your calculator, and I want to see if you plug that in correctly so that we all get the same number. So use your calculator, plug it in. Think about what your answer represents, because you do need to be able to label your answers correctly. So think about how this question is worded, what it is we're talking about, and how you would then put that in as an answer.
Wow.
It's a good investment, huh? In 25 years?
12,072.31,292.
Okay, so now think about what we're talking about. What does that represent? You invested $1,400 and it increased by 9% each year. What would that investment be after 25 years? What are we talking about?
So, are we like distributing it?
Nope, you're plugging it into your calculator exactly how you see it. We're talking about money, okay? So if we're talking about money and you get an answer that's 120,723.31 da 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 da, we don't care about all the da da da, right? We want to stop where it's dollars and cents. So you're going to say after 25 years, I would have $12,072.31. Okay? Did anyone not get that number?
I don't get this.
Do you have your calculator? Well, you got to plug it into your calculator to get it. What did you get for it? Oh, I see. You did this and then took the power. This is taking the power of this. So just put it in exactly how you see it. Just as one big step right again. So 1,400 parentheses 1 plus.
Oh, I see. It's just like the other way.
Did you get it? Plug it in exactly as you see it. Don't do any of the steps to get it. Just plug it in exactly where it is there. Like zero. There's a zero in front of it. To the left. Yeah, there we go. Anybody else having a tough time? Are we getting it? What's up with that? Oh, that's times 10 to the 10th. That's scientific notation. Increased by 75%. So you did 2008 minus 1985, and that was 33. You should be fine. So that's basically saying if I took that number and I moved my decimal point 10 to the right. So it's like 10 to the 10th power.
So it'd be like this, basically.
It'd be that number, but move your decimal 10 places to the right. Okay, let's try another one. Go to number 3. It says the number of student athletes at a local high school is 300 and is increasing at a rate of 8% per year. Use an exponential function to find the number of student athletes after 5 years. So what is A? What's your initial amount? 300, the number of student athletes. Okay, so A is 300. What's R? How do you write 8%? 0.08, yep. And then T is 5 years. So this number, that number, that number, okay? Just make sure you take your percent and don't call it 0.8, call it 0.08, okay? You need the 0 in there. So when you set this up, Y equals your A, your initial amount, times 1 plus your rate, 0.08 to the 5th power. And some of you are trying to like break things down as you go. Don't do that. Literally plug this into your calculator how you see it. So you're going to plug in 300 parentheses 1 plus, and then I saw several of these too. 0.08 and 0.8 are not the same thing. So just make sure you're doing 0.08 parentheses to the 5th power. And then tell me what number you get when you plug that in. That's the question. Do you have to round? Think about the problem. What are we talking about? People. Can you have a fraction of a person? A decimal of a person? No, it's like there's JMO. He's one person, right? There's Aiden. He's one person. So it doesn't, while it is a fraction or a decimal, here, let's see what the number came out to. 1.08 to the 5th. So, oh, no. 440.7. 440.79, Yeah. So if we are rounding then to a whole person, I would take either one of those because it's a rounded answer and we don't know. Is it going to be the more or the less? I would say the best rounding would be 441 people. Actually, no. That wouldn't be the best rounding because we haven't made it to 441 students yet if that number is growing. So I would say 440 is your best answer because you're thinking about that 300 number is growing. So it's on its way up, but it hasn't quite hit 441 yet. That's a better way to think of it. So 440 students would be that answer. Now, if you tell me 441, I'll probably be pretty gracious on that. Questions on that? Yeah, leave your phone. Okay, that is exponential growth. Now jump down to this one.
Same question, but just check.
That's what I was just going to ask. Does anyone think they can figure out the equation, the difference of it? It is the exact same equation, but instead of adding, you're subtracting, which makes it so lovely. You have your initial amount, 1 minus your rate to the t. This one, if you think about it, that's like 100, and you're taking away a percent, which is why it's a 1, because our percents are getting moved over, okay? So if I subtract 5%, it's 0.95. It's 95% of what it started as. Does that make sense? So it's the same idea. A is your initial amount. R is now your decay rate. We're not growing anymore, we're decaying, so it's on its way down. And T is still the time. Okay, so take a look at number 7 here. And let's see if we can work this out. So right now we separated them. There's growth or there's decay. In the homework, they're not separated. You have to figure out which formula is gonna make sense. And on the quiz, you gotta figure out which formula is gonna make sense. So don't just like rush through the problem and assume it's always a plus or assume it's always a minus. Think about what it's saying. It says the population of a town is decreasing. That should be the trigger that says, okay, then I know this is minus. This is gonna be a decay problem. At a rate of 1% per year. It says in 2000, there were 1,300 people. In 2008, what would the population be? Okay, now this one has a little extra step to it. What is your initial amount? 1,300 people, right? And it's the population that we're talking about. So your starting population was 1,300. Okay. Can you tell me the rate? How do you write that? 0.01, right? You're taking that 1%, so the decimal would be here, and you're moving it 2 places to the left, which means you have to drop a 0 in, okay? So 0.01, and then your T, this is the one that's a little bit trickier right now. What is T? It's not 2000. What? It's not 2008. What is the amount of time that we're trying to calculate? It's 8, right? So it started in 2000 and now it's 2008. So your time is going to be 8 years. Okay, so you have to subtract your years on that. So essentially we just did 2008 minus 2000. Okay, that's how we get this number. So now here's your information. We can plug it in. So we're going to say Y equals the initial amount, 1,300, times 1 minus what number? 0.01, yes, to the 8th power. So plug that into your calculator. I get this number. Keeps going. Is that what you got? What does it mean?
Oh, that's the population.
So what does that mean? What's a population? People, right? So I would say in 2008, there should be 1,199 people. And again, I didn't round it up here because they're saying in 2000, it's this number. So another year, maybe it jumps over that 99 and turns to the 1,200 mark. So just be aware of what it is you're talking about and what makes sense. If you just said 1,199 people, that would be fine too. But I'm just telling you what exactly I'm talking about in this one. Okay? And if you told me 1,200 people, I wouldn't dock you for that. Okay, so we're going to do number 9. And then that's literally all I have for you. You're going to have a ton of time to get your stuff done. Yeah, okay, new thing. Let's not go to the bathroom during the lesson. There's all kinds of time after the lesson. I've had, 3 people go already? That's just a bad use of your time. Finish the lesson, and then when the lesson's done, then you can ask to go to the bathroom. Okay? Sound good? Okay, so go as soon as we're done. We got one more problem. Number 9. It says a farmer buys a tractor for $50,000 if the tractor depreciates 10% each year. Depreciate, do you know what that means? Not appreciate. Appreciate would be get bigger. Depreciate means it's going down. So if the tractor depreciates or loses value, okay, after 7 years, what would the value of it be? So you're going to take this equation, y equals a times 1 minus the rate to the t power. What is a in this problem? 50,000. Okay, what is the rate? How do you write 10% as a decimal? 0.1. You don't technically need the 0 behind it. I mean, you can put a 0 behind it, but it doesn't change anything. And then t? 7 years. Okay, so here's all your information. Now we drop it in. Y equals 50,000 times 1 minus, so your rate now, be careful. It was 0.01 in a previous problem. This is not 0.01, this is just 0.1. Okay, and then your t is your 7. So plug that into your calculator. Exactly how you see it. Oh, that's not right. What did you get? So 23914.845. Right? Is that what you got? Did you get that? No? Are you plugging it in?
This is the.
Oh, you did plus. Right, this is depreciate, so you want to do minus.
This is basically the first question to the homework.
Same numbers?
Just the 10 is a 4.
Oh, yeah. You're going to see a lot of the same stuff over and over. It's money or population or money, values of a vehicle or values. Oh, there you go, food growth. Okay, what does this mean? What does that 23914.845 represent?
A long number.
Money. It's the value of, what was it? A tractor, okay? So if this is the value of a tractor, this is not a good answer. What's a good answer? 23,914.85. Round it. If you called it 8.4, if you didn't round it to the 5, that's fine. I will not be picky if you round up versus round down depending on the problem, because different things can be taken different ways. But this should be the value of that tractor in 7 years. Isn't that awful? You pay $50,000 for a tractor and 7 years later it's only worth that. Cars, it's the worst. What do they say? As soon as you drive it off the lot, it has lost like an insane amount of its value. I don't know what it is. It's sad. Until it gets so old that it becomes more valuable again, right? Just, hold on to it forever and then it will regain value. Any questions on any of that? Okay, if I could just ask for one thing, it would be don't try to do PEMDAS. That is where all the mistakes end up happening if you try to break it down one piece at a time. There is no need for PEMDAS because there's no unknowns. The only unknown is the one on the other side of the equal sign. So just plug it in exactly how you see it. Be really careful that you pay attention to that little symbol. If it's something that's on its way down, that should be minus. If it's something that's on its way up, that should be a plus. Okay, so plus and minus is probably where the biggest issue ends up lying. Just pay attention and you'll